Imagine this. You're an astronaut, drifting through the silent abyss of space. Stars glitter like diamonds scattered across a black velvet cloth. But wait, what's that ahead? A region of distorted space where light bends like a river around a rock. You've stumbled upon a black hole, a cosmic monster with gravity so strong, not even light can escape its grasp. What if you were floating through space and accidentally got caught in a black hole's gravitational pull? What would happen to your body? Would you be crushed, vaporized, or maybe transported to another universe? The answer is more bizarre than you think. Stay until the end to find out what happens at every stage of this terrifying journey. And don't forget to subscribe for more space mysteries. As you drift closer to this cosmic abyss, the first thing you'd notice is the strange way space itself seems to warp and twist. That's the immense gravity of the black hole at work, warping the very fabric of space-time. Time itself would begin to slow down for you, relative to someone observing from a safe distance. To them, you would appear to move slower and slower, your image reddening and fading as the light from your suit struggles to escape the black hole's gravitational pull. But from your perspective, the universe outside would appear to speed up, stars swirling around you in a dizzying cosmic dance. And then, you would cross the event horizon. Imagine a boundary in space, an invisible line drawn around the black hole. This is the point of no return, a region where gravity's pull is so strong that nothing, not even light, can escape its clutches. Think of it like a waterfall. Once you're swept over the edge, there's no swimming back upstream. But unlike a waterfall, a black hole's event horizon isn't a tangible barrier. It's simply a point in space where the curvature of space-time becomes so extreme that all paths lead inwards. You wouldn't feel a bump or jolt as you cross it. In fact, if the black hole were small enough, you might not even notice anything unusual at all, at least not at first. But don't be fooled by this apparent tranquility. Once you've crossed the event horizon, your fate is sealed. You are now trapped within the black hole's gravitational grip, destined for a singular fate. Ahead of you lies the singularity, the heart of the black hole, a point of infinite density where the known laws of physics as we understand them break down. But before you reach this point of ultimate oblivion, there's another ordeal to endure, a cosmic torture chamber known as spaghettification. Let's talk about spaghettification, a rather unpleasant experience that awaits you as you journey deeper into the black hole. As you fall, you'd start to feel the incredible tidal forces at play. Imagine the Earth's tides, caused by the moon's gravity pulling more strongly on one side of our planet than the other. Now, amplify that effect to an unimaginable degree. Near a black hole, the difference in gravitational pull between your head and your feet would be colossal. This is because your feet, being closer to the black hole's center, would experience a much stronger gravitational force than your head. The result? You would be stretched, like an infinitely long piece of cosmic spaghetti. This isn't just a funny analogy, it's the reality of what happens to matter falling into a black hole. Your body, your spaceship, even the very atoms that make up your being would be elongated and compressed along the direction of the black hole's pull. Imagine your body being pulled like taffy, your bones, muscles, and organs stretched into long, thin strands. It wouldn't be a pleasant experience, to say the least. And just when you thought it couldn't get any weirder, it does. While you're being stretched out like spaghetti, you'd also be experiencing another bizarre phenomenon, time dilation. Because gravity affects the flow of time, time would pass differently for you than for someone watching from a safe distance. As you fall deeper into the black hole, time would slow down for you relative to the outside universe. To an outside observer, you would appear frozen in time, your spaghettified form forever stretched across the event horizon. But from your perspective, assuming you could still perceive anything in this distorted state, the universe outside would appear to speed up, its entire history flashing before your eyes in a fleeting instant. Now, you might be thinking, if spaghettification is inevitable, what's the point of even considering what happens next? Well, there's a glimmer of hope, a theoretical possibility that you might survive this cosmic noodle-making process, at least for a little while. But that, my friends, is a story for another chapter. Stay tuned. Could you survive inside a black hole? So you're falling into a black hole, stretched thinner than a strand of spaghetti, time twisting around you like a drunkard's waltz. It seems like the end, right? Well, maybe not. There's a chance, however slim, that you could survive spaghettification. Here's the caveat. This unlikely reprieve depends on the size of the black hole you're falling into. You see, not all black holes are created equal. Some, like the stellar mass black holes left behind after the death of massive stars, are relatively small, only a few times more massive than our sun. Others, the supermassive black holes lurking at the centers of galaxies, are true behemoths, millions or even billions of times more massive than our sun. If you were to fall into a stellar mass black hole, spaghettification would be unavoidable. The tidal forces near the event horizon would be so extreme that you'd be ripped apart long before you even reached the singularity. But if you happen to fall into a supermassive black hole, well, that's a different story. Because the event horizon of a supermassive black hole is so much larger, the tidal forces there are actually weaker. You'd cross the event horizon and experience a more gradual stretching, potentially giving you a bit more time before being turned into cosmic spaghetti. Now, what could possibly happen during that extra time? Here's where things get really interesting. And by interesting, I mean mind-bendingly speculative. Some physicists believe that falling into a supermassive black hole might not be the end, but rather a gateway to something else entirely. Imagine, if you will, that our universe, vast and complex as it is not the only one. What if, hidden beyond the event horizons of black holes, lie portals to other universes, other dimensions, or even other points in time? It's a mind-boggling concept, to be sure, but one that has captured the imaginations of scientists and science fiction writers alike. Another intriguing possibility stems from a concept known as the holographic principle. This principle suggests that all the information about a three-dimensional object, like you or me, could be encoded on a two-dimensional surface, like the event horizon of a black hole. Think of it like a hologram, a two-dimensional image that projects a three-dimensional representation. According to this principle, as you fall into a black hole, your information wouldn't be lost, but rather encoded on the event horizon like a cosmic backup drive. Now, before you get your hopes up about surviving a black hole encounter and popping out into another universe or being resurrected as a holographic projection, I must caution you. These are just theoretical possibilities based on our current understanding of physics, which, let's face it, is far from complete when it comes to black holes. The final destination, the singularity. Let's face it, as captivating as the idea of wormholes and holographic universes might be, the most likely outcome of your black hole adventure is far less exotic and far more final. At the heart of every black hole, hidden behind the veil of the event horizon, lies the singularity, a point of infinite density where gravity reigns supreme, and the very laws of physics as we know them crumble and dissolve. Imagine all the matter that ever fell into the black hole, stars, planets, maybe even other unfortunate space travelers, all crushed together into an infinitely small point. At the singularity, space and time cease to have any meaning. It's a place beyond our current understanding, a cosmic abyss from which there is no escape. As you approach the singularity, the tidal forces would become insurmountable, stretching you not just lengthwise but in all directions, compressing you into an infinitesimally small point. Your journey would end not with a bang but with a whimper, a silent, inevitable crush into the singularity. But even in this ultimate demise, there's a certain poetic beauty. Your matter, your energy, wouldn't simply vanish. Instead, it would become part of the black hole itself, adding to its already immense mass and spin. In a way, you would become one with the universe, your essence forever woven into the fabric of space-time. Of course, this is just our best guess based on current scientific understanding. The singularity remains one of the greatest mysteries of the cosmos, a place where our current laws of physics break down, and we are left to grapple with the unknown. Perhaps future generations, armed with a deeper understanding of the universe, will unlock the secrets hidden within these cosmic behemoths. Until then, we can only marvel at their power and ponder the ultimate fate of those who dare to venture too close. But hey, while we're on the topic of amazing things, check out the video description for a list of cool and useful products. You might find something interesting. The great unknown. So, what do you think? Is a black hole just the ultimate end, a cosmic graveyard where matter and energy go to die? Or could it be something more? A gateway to other universes, a cosmic reset button, or a repository of information about our universe and beyond? If you enjoyed this journey into the heart of a black hole, hit the like button and share it with that friend who loves space mysteries.